Greetings, geology scholars. This is Tom Johannesmeyer. We're sitting here in Highway 14 at a granite outcrop in the Bighorn Mountains. What you're looking at in front of you is the Bighorn dolomite. It's a formation deposited in a shallow marine environment. Below that, you could see, below Steamboat Point, you could see a outcrop there. I'll try to zoom on it here. That's as much as we can zoom. And that outcrop there is forested. You could see it's surrounded by grasslands with some snow here and there. And that outcrop there, that treed outcrop, is the same as the rocks where I'm standing on here, and those are granites that make up most of the core of the bighorns. And I'll pan off in this direction here, and you could see off in the distant skyline is where that bighorn dolomite outcrops. And then a little closer to us, down in the trees, you could see there's one right there, a outcrop of the granite once again. So as far as this region is concerned right here, the granite sits at slightly lower elevation than the bighorn dolomite does. There are other sedimentary layers on top of the bighorn dolomite that extend outward to the east into the Bighorn Basin. Our riddle here is whether those granites are older than or younger than the overlying rocks. Now, this has actually been determined through radiometric dating that the granites are in fact older. They're about 2.8 to 2.6 billion years, whereas the bighorn dolomite above it is significantly younger at about 500 million years old. But I want to pretend that we don't know that, and we're going to use just purely field relationships to try to determine whether or not that granite is older or younger than the surrounding rocks. So if you think this through for 1 second, there's really two possible relationships. That granite could actually be a younger intrusion of magma that intruded up and into the overlying layers, making it younger than the overlying rocks. But another possibility is that granite had crystallized at depth in the past, and weathering and erosion then removed the cover rocks, exposing the granite on its surface, and then the sedimentary layers were deposited on top of that granite. So that is basically your assignment for this discussion and reply topic, is to provide an actual kind of a research proposal in a sense. What would you look for in the field? What kind of relationships would you look for in the granite and the overlying rocks to determine, is the granite older than the overlying rocks or younger than the overlying rocks? Now, many of the concepts discussed in Chapter 9 on geologic time, particularly the discussion of relative dating techniques, are really all you need to be able to answer this question. I'd like you guys to be able to post your response individually. I don't think the group project worked so well last time. So just individually post your proposal as to what you would look for in the field to determine which one of the scenarios is true. The granite is older or granite is younger than the overlying rocks. And after having posted those initial responses, I'll then ask that you reply to at least one other student's posting in order to get full credit for this assignment. So as always, please ask me lots of questions, and hopefully you can get to the bottom of this granite mystery.